What was your interest point in AI? How did you get started with it?
Yeah, I can take it from the beginning.
That is a bit of a long story, though. I don't know how deep you want me to go.
I don't think the answer is going to be so great.
Whoever intends to work in this field must have been a roller coaster ride.
So when I entered Cornell, I was not a CS major. I was actually a physics major.
Questions. I mean, where do we start? So maybe I'll tell people a little bit about my background, and then we can talk about what worked and what we didn't work.
Okay, I'll tell you the whole story. I'm getting excited about this now.
So when I entered Cornell, I was not a CS major. I was actually a physics major. And then I switched to CS. And when I switched to CS, my first I was kind of naive and probably willingly naive. I wanted to be naive about what I wanted to do. That I thought that would make me pick what I really love. And the first thing I liked was graphics, as I said. So I was doing a lot of research in graphics. I quickly realized that maybe this wasn't the greatest thing for me in the long run. That's when sort of ML started becoming a hot topic. You know, the Andering course came out, everyone was talking about it. Neural nets were all the rage, ImageNet records were being broken. I was reading, Karpathy's blog and stuff like that. That's when I sort of realized that this is obviously something that's changing everything in computer science. And I think the moment that sealed it was, I don't know where I read this, but it was like, computer science was split into so many domains of like computer vision and graphics and this and that and natural language processing, and they all had their own techniques and their own entire disciplines built to like figuring out how to solve these problems and the various problems in each of these disciplines. And all of a sudden you had almost a silver bullet, which is like put a neural net on it and it'll do better than everything you've done for 20, 30 years of research. And that is mind blowing. Like, just to think that rarely happens in any industry, right? Like where a silver bullet just solves a bunch of problems, and it was happening with ML. So that's when I realized that maybe there is something here. And then, as I went to the industry, I sort of saw the difference between the theoretical papers that people read versus what actually happens in practice, which is, very, very different from each other. And that's sort of how my interest grew.
Sophomore year, I was still trying to figure out internships, what I wanted to do. And I was told that working with professors is like a good way to, get your hands dirty, try to, learn stuff. So I reached out to a bunch of professors, David being one of them. His lab, he's now at MIT, does machine learning for healthcare. And I come from a family of doctors. My mom's a doctor. I almost went to med school in India. The fact that you could predict who was going to get a certain disease from their clinical records was just so amazing, fascinating, and mind-blowing as like a concept. I was like, wow, computers can do that. And so that really, just being in that lab, being exposed to that environment, and I was like, wow, everybody knows so much more. I'm barely getting the hang of CS, and now there's this whole new world out there. But it was very exciting, and that kind of prompted me to work in David's lab. I ended up working in his lab for 2 years after, and then to even Andrew's lab at Stanford, they do machine learning for medical imaging. So kind of different in terms of what they do, but still in healthcare. So really, and then just being in this field, I think it's super exciting how fast it's growing, all the potential impact it could have. And having gotten various experiences just motivated me to stick around.
So I was really interested in like cloud computing and parallel programming, like from an operating systems perspective. And so my undergrad advisor actually worked on like GPU parallel programming. And so we got started on a project, and images and like graphics in general has a lot of need for high process like parallel computing. And you have like embarrassingly parallel problems there because each pixel you can possibly work independently. So I got started on that, and from images basically there, I was like, this is actually pretty interesting. You can do very interesting things with it. And then I took a machine learning course and computer vision, and then basically that's how it got started.
It's sort of a random walk over opportunities is really what it was. I did an undergrad in both computer science and psychology. And I was pretty, psychology was having sort of a replication crisis where studies weren't replicating. And a lot of what I learned in my undergrad was like stuff Freud said, which is to me like not good science. It's like closer to philosophy, right? And so it's just like, this is not data driven. Like, what is going on here? So I had this dream of like, I want to use machine learning to understand like psychological questions and like use machine learning as the next set of statistical tools. Like psychology already uses a lot of statistics. Can we use machine learning to get better answers? So that's sort of where I started. But what happened is I went to my first NeurIPS in 2015 and I just fell in love with it because I was like, oh my God, we're living in the future. Look at how cool this is. AI is real. This is happening. Like, I was so excited. I remember some of the papers I saw. This was Neuropsych 2015. There was a humanoid robot that had learned to climb up on surfaces by like putting its hand on the surface and pushing itself up, and then like putting its leg up and climbing up purely end to end with like no prior. And that was just like the most efficient way to get a human body onto a ledge. And I was like, this is so cool. And like, just, you know, a bunch of results where I'm like, oh my God, like AI is so good. Things are really happening. And then I switched. I really moved away from what my advisor works on during my PhD. So that was somewhat challenging. By the time I was like writing up my thesis, which I think is your question, you know, things had changed significantly. And so I think it was more like trying to show the affective computing flavor in the deep learning and deep reinforcement learning problems I was working on.
It's because it's an extremely powerful tool that we can use and we can be built on top of to solve problems in any field, basically, that we want to. So that aspect of machine learning is very exciting for me. And the reason I focused on the systems part, like at least a major contributor to the rise of AI and deep learning, was the invention or creation of very powerful systems and chips that enable these learning algorithms to run on large data set, to learn from large data set, and to like really push forward the progress of AI. And so the way I think about it is time to return the favor and use machine learning to build better systems and chips to kind of like close the loop and make sure that this progress continues.
You know, for me, my journey was obviously non-traditional in a lot of ways. I have an MPH, but really when I came to Stanford, you know, again, I hadn't been exposed to anything related to machine learning, but I had been looking for an avenue to do NLP because a lot of, you know, what we were working on were large data sets of radiology images and reports. And if you know much about medical imaging, which sounds like you do, you know, we don't have structured labels, right, for what's on the image, right? It's a free narrative text. And that poses lots of problems to scale and curate and, you know, structure data sets. And so I was, you know, previous to that, I had done it manually, which is obviously not ideal. And then sort of getting to know some of the resources here, I was able to kind of interact with that community really early on, say, hey, I've got this really big data set. I'm really working on this automation. And then, you know, I just started to become real curious. I mean, I really felt like a light bulb clicked on for me. The more I learned about it, the more potential I saw. Listen, I spend, you know, up to an hour and a half a day just dedicated to trying to read, trying to understand, asking a lot of questions on Slack and email with my colleagues. And over time, I've kind of gotten a casual education in this and my understanding of the principles and my own domain expertise to plan out how I might leverage that, you know, sort of innovation in the medical space. But my journey was certainly casual, but I've tried to, I don't know, build on my learnings and maybe make it more available to others as well.
And then I moved to Wired magazine, which you mentioned. And it was at Wired when, you know, the AI field really started to take off in its current form, meaning, you know, the idea of a neural network really started to work for speech recognition, for image recognition. And our aim at Wired was to figure out where the big technical changes were happening that were really going to impact the world and really cover that. And this became the key area, right? As we started to see the results in speech recognition and then image recognition, you know, with the AlexNet result 2012 from Jeff Hinton and two of his students. That's when we really started to cover this area hard. And it was a good bet on, you know, because that has just continued to drive a lot of the change in this area, right? It's not just image and speech recognition. It's natural language understanding now in a big way. This, of course, plays into driverless cars, all sorts of other robotics. And then it led to my book, you know, which is really about the people who believed in that idea, the idea of a neural network.
I think in many ways, even though my journey seems like a zigzag, it was always motivated by problems that I was curious about. And also, it was always motivated by a desire to model the world with data. I started out in economics mainly because I loved economics. I grew up in Africa, so economics was one of the most technical fields that I could see on day to day. A lot of the people that I saw that were technical were from the World Bank or the IMF. And I thought this is a very interesting way to model the world. So after I graduated, my undergraduate degree was in economics, I actually came out to work in economic consulting, in particular for antitrust cases. But at the same time, what was interesting is I was spending my weekends volunteering. So I started a nonprofit, and I was working with nonprofits from where I'd grown up. So from areas of the world that I'd grown up in Africa. And there were two things that happened. So one of the first things that happened is I started realizing there were more complex ways of modeling the world that were very fun. And that was the first turning point. And after I realized that, I just wanted to learn more. So that's when I joined Udemy. And I consider that to be a really is the brute force stage of my career, where a lot of days I would be studying coding before, working all day, and then going to night classes in coding. And I think that after being at Udemy for 2 years, I realized I had learned so much I wanted to teach. So I paired it with teaching. So I was teaching machine learning. And that's when I actually relocated to Kenya to teach machine learning. And then at that point, I got an offer from Google to join the brain residency program, which was also very unusual at the time, this whole brain residency. I was part of the second cohort. And at the time, I thought this is a very interesting opportunity to try research because I had worked on all these applied problems.
Like later on, maybe in middle school, I realized that there's this thing called programming, which is much better than doing like 3D designs and all the other and building animations, etc., things that I thought are a good thing to do with computers. So that completely changed my mind as to the possibilities of what you can do through this device that is in front of you. So I grew up in Iran. This is our high school in Iran, one of which was our physical ed education, I guess you call it. And the teacher that we had for that course told me that I would not pass you unless you, she handed me this big, mini, documents, unless you translate all of these, English documents to Persian. And so at the time, I had, maybe 2 weeks or so. And I'm, sitting, I'm like, oh my God, how on earth would I be able to pass this course by translating these documents in 2 weeks? And, at the time, I was just thinking to myself that I spend my entire life in front of computers. Shouldn't there be a way of automating this? And I was like, yeah, blah, blah. And so I kid you not, by that day, I did not know that the field natural language processing existed on the face of the universe. And I had no idea what machine translation is. So I just literally Googled how to automatically translate, of course, English to Persian. And that just, one thing led to another. I basically came across natural language processing and all the subfields of it, like being machine translation, text summarization, etc. And so anyways, through that adventure of kind of the thinking beyond what I was already doing with AI, I realized that there's this entire other subfield of AI, which is actually even more challenging.
And then let's say at some point between the primary and secondary school, I think I discovered algorithms. So I was also very excited about the idea of writing rules that we can provide input to those rules, and we could really get very variable and diverse output out of those rules. And if you keep on digging in those algorithms, you could see they could really build very complex, let's say, programs and very complex systems just by coding up those things. And it was very impressive to me. Therefore, I decided to study informatics at my hometown university in Wrocław, where I, by studying informatics, you discover that there's some different subfields in computer science, and one of the subfields was machine learning, where basically you have the ability of using a large number of data to basically discover the algorithm, let's call it a bit in a hand-wavy way. That by feeding a lot of data points, you just don't need to write the rules anymore. You can just learn the rules from the data, And then you could see that those rules, generalizes to different scenarios. For example, an image classification setup, if you have enough images of dogs and cats, you can build systems that can distinguish between those two without any particular intervention on let's say on our end. We don't need to write any rules. We just need to write machine learning system that learn from the data, and then everything gets solved.
Yes, absolutely. So if you rewind enough in my life, I was obsessed with languages, foreign languages. I still am. I still love them. Specifically, I got really deep into Latin, the classics, and loved reading poetry. So that's what I did at Harvard, which was my undergrad. I found computer science as just a whim in college. I took the intro course mainly because I was just really bad at technology and I didn't think I had anything to lose, actually. So I thought I could just help myself a little bit after breaking like 5 phones in a row. So I took it and I was like, oh, this is actually quite mathy. I like math. I fell in love with it mainly because one of the professors in one of my classes, the first day he said, it's never the user's fault. And I just thought, it's never been my fault. And then I realized I can design systems that don't make people feel stupid. And then that very much has carried on with my career. And yeah, so that's been kind of the theme that's driven me very much into this area.
I was interested in AI about 5 years ago, and it was because I came from a compute world, and before NVIDIA, I worked at Cisco managing the Unify computing system line, which is another server. And at the time, it was actually a lot of analytics workloads. So remember that there was a peak of like all the data started like peaking. That was the time that I was in the thick and thin of the data world. And that really laid the foundation for us to be able to have the second wave of AI. And the part that in particularly interested me and piqued my interest was NVIDIA announced its DGX systems, which is the AI compute line about 5 years ago now. Yeah, that's right. And that was when I decided, well, it's either now jumping on the train or miss it. So I just decided to jump on the train. And because of the AI's promise, be able to automatically detect, segment, and classify information a lot more efficiently, it's promised to streamline a lot of our productivity. And any of the industries that we work in is going to open doors for just an imaginable outcome. And that's why I'm in this industry now.
I learned about machine learning from that perspective of the applied domain. And the first time I remember actually using a machine learning technique was in order to classify state of train platforms, where they'd have this problem where trains would be off schedule. There'd be some accident or some natural disaster or something that would knock the trains off schedule. But it wasn't that simple in densely populated urban environments, because if you did that scenario as the subway system and these commuter train systems would do, the train platform would become overpopulated, and there would be more accidents or more delays because there'd be so many people that they couldn't stand on the platform, they couldn't get on and off the train easily. And so we were trying to classify the state of the platform. Is it full? Is it moving? Are the people moving correctly on it? And so that was the first time that I saw SVMs trying to look at a picture of a train platform and decide, are there too many people here? And is this train too full? And I thought that was kind of magical, and that the effect of it was kind of magical. That made so much sense to me. Okay, I'm going to be like a fortune teller, and I'm just going to linearly project my idea into the future, and then I'm going to know what it is. That seemed both magical and really understandable at the same time, and that's why I kind of changed my emphasis, and I went into machine learning.
Around 2014 or thereabouts, I believe Merck sponsored a Kaggle contest for deep learning and drug discovery. So I didn't participate in the contest, but I kind of watched the results from afar. And I think George Dahl, who's one of, Jeff Hinton's students, won this contest by making a model that was kind of considerably more predictive than the next best contestant. So I think that spurred my interest. I was also lucky enough to work in a research group that, allowed me to explore these questions. So my background as an undergraduate was in pure mathematics. So I decided to join a lab that focused more on studying proteins and chemistry and things like that. And I was still trying to figure out what I do in the lab. But I think when I kind of saw this Kaggle contest, I became interested in kind of trying to extend and build upon these results. And luckily, I was in an environment where, the other folks there had the expertise in the parts of drug discovery and chemistry that I as a more kind of a computer science mathematics student, didn't have at the time.
I think since I started school in 2015, 2016, 2017 were kind of like hype years, I think, where deep learning frameworks like TensorFlow 1.0 came out, whatnot. And I just found all of my peers and classmates taking these classes, like Andrew Ng's machine learning class. I think it's on Coursera also, and Percy Liang's intro AI class. And I remember taking those my sophomore and junior years, seeing everyone else doing machine learning projects. All of these classes have final projects, which are kind of machine learning mini kind of a Kaggle projects. And I think one thing led to another. I just kept following down the rabbit hole.
Only after being involved in the research field for around a year or so did I realize, hey, this is really fun. There's a lot of open, unsolved problems in the world. And I liked applying my engineering principles to be able to solve those problems. I'd done a couple of internships at a hospital in itself. And I guess I realized that I didn't really like being in a hospital. I wanted to be able to help patients, but maybe I didn't have the emotional fortitude to be able to see sick people all the time and to be able to interact with them. So for me, I really figured that, hey, if I can be on the sidelines, if I can build new tools and build new technologies that can help those patients, I think that would be a win-win. And that's how I continued staying more in research as an undergrad, and then realized, hey, there's still a lot more to be done. And that's kind of how my academic journey started.
In school, I actually studied biology. I thought I was going to be a doctor, along with, I guess, most people who start off in school. And then midway through, I realized that I didn't want to, go down the medical school path. And instead, I wanted to, try my hand at tech. And that's when I got an internship at Microsoft. That was my first taste of, actually being part of a company whose whole mission is to just build things for people. But then right out of college, actually, I went into consulting. And the reason why I started off in consulting instead of going straight into tech was because I felt like as a new grad, I just didn't know enough about the world to truly make a decision. In that process, I realized, okay, I want to get back into what I enjoy most, which is being close to products and being in technology. And so I had a lot of trouble breaking in. And so the first thing I did actually was go into a market research consumer analytics role at Snapchat. So that got me a little bit closer to kind of where the action all happened. And then about a year in, I had the opportunity to talk to the founder of a really early stage company. And I started off in a product analytics role, basically similar to my background, but within a couple of weeks, basically transitioned into OPM.
But I got the opportunity to visit the Sunnyvale headquarters of Yahoo while I was in India. Like I was working in the Indian office. So when I went there, I just got like a huge exposure to the kind of work people were doing in there, in the Sunnyvale office there. Like, they were doing data crunching and, developing different models, algorithms to rank content. And that really intrigued me. And I was like, what is this thing that people are doing, and why don't I know about this thing? So that was that was a kind of exposure that pushed me into this field. The impact of the field sounded very interesting. It sounded something that not everybody was doing. So even it felt very niche.
So as you can imagine, back then we did not have any machine learning course, right? So I really started trying to do things hands-on. And I think the root cause of that was that I used to go to a lot of hackathons back in college. And, hackathons are a very practical kind of an atmosphere. It's like a sandbox where you have 24 hours to try something out or 48 hours to try something out. And I think that's really where the more practical aspect of computer science really appealed to me. And so eventually, a year later in 2012, when Coursera came out, and then MOOCs started, becoming more mainstream, and then the machine learning course by Andrew Ng came out. And again, I didn't have any background in machine learning or AI or anything in that domain back in 2012. So I started out this course, and throughout, I used to look for mentors at hackathons or at all these different places, or even my college professors. And I would just ask them all these questions that I had. And I think that really helped me figure out what I really liked. And I feel that I really liked the AI bit when I tried it out. And I think that's why I've stuck to it for a longer duration of time. And we'll see how that goes.
So I select medical imaging. It's not initially not my decision. Then I just contact one of the professor in my department, computer science, and he is working on medical image analysis. Then that's the time I start working on it. But now, as the time goes, I just think, oh, deep learning is a really powerful tool. So it can specifically beneficial for something that human really hate to do it, because something, maybe it's a really boring, tedious, time consuming, like a lot of dirty job. And deep learning at the same time also good at some job like a human cannot do very well, like calculating some pixel-wise analyzed human eyes may not be capable. So so by understanding these two advantages, I think medical image analysis may be a good application for deep learning. One of the great best application, because radiologists every day is so busy, and a lot of small things, detailed things they don't want to do, then you can use deep learning. And something like a radiologist cannot tell, like maybe need a biopsy result, and deep learning, hopefully if deep learning can do it, it's also very good.
I got started with NLP, specifically the domains of recommender systems and IR while I was in undergrad. And yeah, I decided to get a PhD mainly because I thought I wanted to pursue those topics in like real depth. So yeah, that's how I ended up here at the IR lab in Emory.
There are a bunch of things that eventually led me into this field. So I think one of the first interactions with AI that I had was through this startup that I was a founding member of. It was a search engine that would allow a better semantic search for research papers. So I think that was the first time I was introduced to NLP as a proper computer science discipline field per se. And the other story that starts from my rural internship, to like really understand from the inside what the challenges that are that the society faces currently. And I saw that a lot of people were using mobile phones, but they were not very comfortable using everything in English. Still, they were not able to leverage the amount of power that a mobile phone, something as simple as a mobile phone and even the other things like laptops or computers, they had everything, but they couldn't really use that power. And one major thing was that was the language. And it's a very well-known field that people are now working on. It's called low resource languages, where they're trying to make things more accessible in languages. Also other than English, yes, but also in languages which have very limited training data available. So that was something that eventually I connected with during my internship at CMU, at NTU. And that kind of gave me some motivation to go into NLP.
As far as projects that I did on my own was about finding the tempo of a song, but finding more than one possible tempo. I never called it data science or machine learning in those days. But I mean, even before that, I was doing stuff, related to data science and machine learning, but it wasn't, the phrases didn't exist. So I took Andrew Ng's course, a Coursera course, and I realized that actually I've really been doing machine learning all along, although I was using maybe more primitive techniques than the kind, they're already much more sophisticated than what I'd been doing before, and they're now even more sophisticated than they were then, and progressing very too rapidly to keep up with. But
so when I was an undergrad, during my third year of my undergrad, to be precise, I was watching this video on self-driving cars, which was actually a part of a lecture from Professor Andrew Ng. As most of you know, he was at that time at Stanford, and I was really interested in knowing how these self-driving cars function properly. At least in that video, they function properly, but still they're not near to perfect. But I just want to know more about those. So then I found out that machine learning is sort of like a technology which people use to drive these kinds of applications. And I took this course from Professor Andrew Ng, which was like which might have been the starting point for most of us for machine learning.
I think I've always been interested in computers. Specifically, I think ever since I can remember. It's just, I think specifically for kids of the 90s, we've seen a lot of things, and we've seen a very rapid change in technology and just development.
Looking at AI was when I was 12 or 13. It was people who modify games. I was pretty heavily involved in that community. I actually led Age of Modding, which was the biggest modding community at that time. So we used to take, we used to look into building game mods, and that was the first time when I looked at how different civilizations played Age of Empires, and it was just like a text file with a bunch of if-else conditions, which is not really AI, but that was what AI was at that time. So that was my first impression of it, and didn't seem too excited by that.
So I graduated from DISET in 2015, and I remember at that time machine learning, artificial intelligence, data science, it was hardly a thing in 2015. I happened to visit the Google campus in Mountain View, the Google headquarters, and Google was testing its self-driving cars outside the campus. And that's something which I saw in action, and immediately I was like fascinated. I was like, wow, okay, this is a game changer. Like if these self-driving cars actually become a reality, and we see them being like widely adopted, this has like tremendous potential to like disrupt a lot of things. So that's what like really got me interested in machine learning.
I got started in 2014, I think. So that was in the third year, and we used to have this course on information retrieval with Prasanjit Majumdar. Anybody from the city knows him. Yes. So so that was the course, and there was this research paper thing that was going on. So we participated in that, and we won the task for Gujarati at that time. It was just a language classification task of that sort. At that time, it wasn't really called AI, right? So there were no specific terms like machine learning, AI, like all these terms didn't exist. And yeah, that got me curious, right? So I took a job in web development, did it for a year, and I was like, no, I need something else. I moved to Melbourne, started working in a company called Appster. I was mostly working on client projects. So their major customer base was startups and just people coming up with cool ideas and how to implement them. And I was mostly responsible for their machine learning components in any of their products. I spent most of my 6 months building a chatbot, which would answer like sports questions, give you live updates, personalize updates based on which team you're following, what's your favorite player, stuff like that. And yeah, now I'm working as a consultant in Servian.
So from my second years in my undergrad, I had like a sort of fascination for image processing in general. That time it was not like you were not doing any kind of like deep learning or neural network stuff. The things that would at least taught, like I started out, so I was just reading out on the existing literature and stuff. So that was all about like SIFT, SIRFs, those sort of features, and how do you build edge detector models and stuff like that. From that, it slowly grew into a bit of NLP stuff. I remember I took a course under Prasanjit Majumdar for doing information retrieval. It was quite good. We did actually a lot of basic stuff that I know about NLP comes from that course. Apart from that, it all started I would really say it all really started in earnest when I started my master's.
It was during my research internship at IIT Bombay. I worked on recommendation system, in fact, with recommending educational videos and stuff like that. I took some course. There weren't many machine learning courses offered in DICT back then, but I did one graduate level course with Dr. Prasenjit Majumdar on information retrieval, and that was probably one of my first coursework where I learned machine learning courses and that's where I picked up my interest in this domain.